It brings me a great pleasure tonight to present a panel on oil and gas. I'm sure you have heard of shale and you have heard of the problems with fracking. A few months ago, I introduced the idea of holding a panel on oil and gas, specifically innovation in the space, because I think, and you have heard it from the industry, that a proper portfolio is a diverse portfolio that includes both fossil fuel as well as clean energy. Our panelists tonight and I believe that much innovation is needed in the space and can bring a lot of efficiencies, whether in production, whether in other ways to find and explore this fossil fuel subsurface. It's the first event in Cambridge that addresses innovation in oil and gas. And I have the pleasure to be joined here by esteemed speakers from the industry. Please join me in welcoming them. We will proceed as follows. First, there will be an introduction by the speakers. So each panelist will take 2 minutes to introduce themselves, their job. Then after that, there will be a moderated session. And in the remaining half of the time, we will move it to the audience for your Q&A. So first, Dr. Michael Pavia, start by you. So go ahead, please. No, you can. Oh, you want to? Yeah.
Can we turn? Oh.
You see, I know nothing about technology because I think I'm going to be able to figure out how to do this. But anyway, thanks, Henry, for the invitation to be here tonight. So I represent Glory Energy. I'm Chief Technology Officer at Glory. And I'm going to take my 2 minutes, maybe 3, to show you quickly what we do, and then we can discuss it more as we proceed.
That's a microphone.
That's the microphone. It's always embarrassing for a technology guy. So I'm sure there's a fact here that most of you are very familiar with, but 2/3 of all the oil discovered remains in the reservoirs today. It's not accessible.
I'm sorry, could you speak into the microphone because it's being
It's
recorded?
not accessible with technologies or economics that allows us to get it today. And that's about 1.2 trillion barrels of proven reserves and probably 2.4 trillion barrels of non-accessible reserves. So what we've done over the last 6 years is develop a technology called AERO. It stands for Activated Environment for the Recovery of Oil. And what this technology does is allows us to get some of this 2/3 of the oil that remains in the reservoir out. And it's an efficient, it's environmentally safe way to extract the oil. And it really contrasts dramatically with some of the brute force technologies that are currently in use. Just 2 quick slides. What we do is we go into a reservoir. These are usually water flooding reservoirs that are nearing the end of their productive lives. We go in, we analyze the water, the microbes that naturally exist in these reservoirs, analyze the oil, and then we develop a custom blend of nutrients. We introduce those nutrients into the injection water in an existing water flood, so no new infrastructure essentially. And what this does is these naturally occurring microbes then do 2 things. First of all, they make surfactants, which reduces the interfacial tension and frees up the oil to come out. And secondly, the natural growth of these microbes changes water flow patterns. And together, these things, you're going to see the results on the next slide, really generate a substantial amount of new oil. And importantly, what we don't do is, as I said, very little environmental impact. We don't drill new wells. We don't add unnatural organisms. And so we're really attuned to the environment here. And this is just the last slide I want to show you. This is, as you probably can see, that pink line is the decline curve of a reservoir, a water-flooded reservoir producing. And I'm just going to give you just the highlight here, but where that vertical line is, about at 300,000, that's where we introduced our technology. You'll see what happens over just a period of 2 to 3 months. We start to see oil production very significantly increase to the red line. And just over the life of that little bit of the project, that's approximately 250,000 incremental barrels of oil produced. And on the bottom of the slide, you'll see the same thing. You'll see the same thing in oil cut. How does this compare cost-wise? And I won't go into this in a lot of details. We're seeing about 62% increase in production on average of the dozen or so projects we've done in the field. And on the right side of this slide, you'll see what the cost of this is. It's about $5 an incremental barrel of oil. We'll compare that to some of the other technologies and current uplifting costs of $50 to $80. For example, CO2 and others are in the $50 range. So what we have is an environmentally friendly technology that uses naturally occurring microbes and produces a lot of oil very quickly. So I'll stop there. We can discuss it more.
Yeah, we're going to discuss more. Okay, well, thank you, Mike. Thank you, Michael. We're going to discuss more about the technology going forward. And again, just one point about his technology. Glory Energy is about conventional, so is not yet applied to shale. And yeah. So next speaker is Daniel Kodazi from Schlumberger, then Jonathan Kane from Shale, then Dennis Costello from Bremer Venture here in Boston, and John Gilmore from Invensys outside Boston, 495. So please go ahead.
So my name is Daniel Kodazi. I work for Schlumberger here in Kendall Square. Schlumberger, we are a large oil service company, meaning what we do is we help the likes of Shell to find and produce hydrocarbons. And to do that, you need all kinds of instruments and systems and software and tools that are so unique that the only way to come up with those things is to do them yourself. A good example to illustrate what we do is to draw an analogy with the medical field. If you have a patient, you want to figure out what the issue is with the patient, you run a series of tests, a series of measurements, including radioactive type of measurements, including NMR, nuclear magnetic resonance, including fluid sampling and analysis, including acoustics with ultrasound. Well, guess what? That's exactly what we do, except we do it not around the patient, but from the bottom of the hole, looking at the rocks around us. So that's what we do on a daily basis.
Schlumberger stands at the front of the technology into the upstream business, which is this is where the source of the fuel. And we look forward to hear more about it. Jonathan?
Hello, yeah. Hello, everyone. I'm Jonathan Kane. I'm the Shell's liaison at MIT. A little bit about myself. I did my PhD at MIT about 10 years ago. Hello? Okay,
Yeah.
Oh,
good.
way
Much
better.
better.
Thank you.
Yeah, so I did my PhD here 10 years ago, and I've worked in conventional upstream oil and gas. I've been in New Orleans, Houston, and then I did a lot of my career in R&D, upstream R&D for Shell, and I've been here at MIT for the last few years. And my job, I'm the liaison, so I consider myself, in a few words, I'm like the grease on the rails that helps the relationship go smooth between Shell and MIT. We do a lot of research there. We have more than 25 projects. I'm based in the Energy Initiative. It's where Ernie Moniz, the current Energy Secretary, was before he left to go to Washington. So that's where my office is. And we have a lot of other operations here separate from me in the Boston area that are very recent. We have Shell TechWorks Innovation Center. We have STV, Shell Technology Ventures, which is an investment capital arm of Shell. And I could talk about that stuff. I don't know, it depends where the conversation goes.
Yeah.
So we'll see.
Yeah, sure.
Thanks.
Wonderful. Dennis?
I'm Dennis Costello with Bremer Energy Ventures. I know a number of you in the audience, been around here a long time. We're on our third energy technology fund. The first one was 2001. If you look at our portfolio, it's about 65%, that's not me, 65% energy efficiency, and the rest is production of both liquid fuels and electricity and chemicals. We include that in it. And we have traditionally been a lot in what you'd call clean tech, but we have done a number of deals since 2001 in more conventional energy, in coal, in natural gas, and in oil shale in the past, and obviously with what's happening in both this sector and the clean tech sector, we're more and more interested here. So we are looking at a number of deals, and we're working with Shale right now in a number of capacities here. So that's what we do. It's traditional venture capital. We invest in technology companies. The latest fund is $300 million. It's about 60% invested. We manage in total, which is the way venture capitalists talk about revenue. We have a cumulative amount of about $600 million under management. But, there's only a $300 million active fund. So that's what we do, and we're active in this area as well.
Good evening.
Yeah, please.
John Gilmore. I'm with Invensys, which is an automation company. We deal with the process industries. That's not only the oil and gas value chain, production, processing, pipelining, refining, petrochemicals, fuels. We also deal with power generation, pulp and paper, mining and metals, pharmaceutical, water, wastewater, anything about processing materials that we need in our lives. I got to talk up louder than the girls after me back there. You didn't throw anything, that's okay.
We don't throw things here.
Oh, that's good.
That's later in the program.
That's later in the program. All right, there we go. Can I duck you? My particular area is upstream oil and gas. I start out at the reservoir and deal with all of the processing facilities up to the refinery fence. Some of my colleagues take over and try to make them into fuels or feedstocks that make fabric or clothing or whatever else you might need. So I deal with the oil and gas sector. Invensys is about 10,000 people around the world. Our headquarters are now in Houston, but we started in Foxborough, Massachusetts, which is where I'm headquartered. We actually started a little over 100 years ago. Our first product was oil pressure gauges for instrumentation for automobiles. You ever seen the Stutz Bearcat? It's a Foxborough pressure gauge. So we do a lot of stuff in that environment, and we make instrumentation and automation solutions.
All right, thank you very much, John. Thanks for all of you. So I will jump in immediately into the Q&A. So, I mean, now oil and gas has come to the surface because of the revolution that we are witnessing in the shale. And speaking of the innovation, and before, we have perfected innovation in the conventional for more than a century. Yet still now, when we started with the unconventional, we are still hearing problems about recovery, problems in exploring and finding it, beside the environmental problems which all the industry is addressing it. But speaking of the technology and innovation that we have perfected in the conventional to help us find and recover these the fossils from subsurface. Why many of these? What's the challenge with the unconventional? Why many of these technology cannot be applied straightforward to the unconventional? If any one of you can start, what's the differentiating thing with the unconventional compared to the conventional?
Let me give a try at it. The primary difference between what we call unconventional shale gas production, shale oil production, and conventional production has to do with rocks. We're trying to extract a fluid from rocks. You may not think of it this way, but rocks actually let fluids flow through. Normally, we're drilling into a sandstone, we're drilling into a carbonate, a limestone, and they have a significant flow rate. When I punch a hole into it, the natural hydraulic pressures that exist in rocks drive the gas or oil and the water that are there to the well, and it'll literally push itself to the surface in most cases. And eventually we'll start pumping when the pressure drops low enough. The problem with unconventional gases is that it doesn't flow. The rock is virtually impermeable. Typical shales have permeabilities about 10% of concrete. Okay? So how do I get it out of there? What I do, what the industry does, the Schlumberger guys more than me. I just control the process. He does the work. Pump water at high pressure along with sand. The high pressure causes the rock to crack. The water rushes in and carries the sand in with it. And we take the water out, and the sand keeps the cracks open. That's the nutshell.
Okay.
We're cracking the rock so that we get enough surface area so that we get reasonable production flow out of the rock. Okay,
Right.
quick enough?
Yeah, sure. For now, yes, definitely. And Daniel, can you tell us a little bit why innovation, many of the innovation that we know for conventional is not working, I mean, complementing with what John said?
For many reasons. The first one is that our knowledge of the transport and storage phenomena in unconventionals is still very poorly known. If you go to a conference these days, you will see very quickly that the thinking is still evolving very, very much in that field. And yet it is an industry which is almost very mature now, right? And it's very rare that an industry matures on a technology or on principles which are vastly unknown. The second point is the economics. Basic number, a well offshore costs between $200 and $300 million. A shale gas well, total cost is between 6 and 8 million. The economics are totally different. Yeah, completely different. Yet the equipment that we tend to use to log, measure, evaluate just happen to be the same. So we do have a situation where it's the problem is asking for data for process, right? But the data process managements we have available today just are not economical. So it's our job in the service industry and with the operators to come up with means which will allow us to optimize these processes in an economical fashion, and that requires a lot of innovation, which we can probably talk about maybe later in more detail.
And just to add something here, I don't know if Dennis wants to add. I don't know if you want to add anything, Dennis. Okay, that's fine. But just to add something, that the recovery from the offshore is way higher than any typical shale. Definitely, it makes the economics much better on the offshore.
Way, 30%.
Versus 10%.
We agree, but that's the number.
So, okay, that's so Mike. So, I mean, thank you. You answered many of the questions that I have about your technology and whether it's environmentally friendly. And can you? I mean, you said also about the size of the market, like around 600 million.
I'll give you another answer. So if we take what I call low-hanging fruit criteria for projects that we select, sandstone, relatively low temperatures, low salinity, that represents about 8 billion barrels of production a year. So if we just take the very low-hanging fruit and get even a 10% incremental increase, the market is huge.
The oil, you were speaking about oil.
This is in traditional sandstone, conventional oil. Now, what can we do? So I'm a biology and chemistry guy. So I need to put microbes in the reservoir, or I need to put chemicals. And shale, we can't do it.
And friendly chemicals.
That's the reason you just heard, because we can't. It's so tight that we can't get microbes can't fit in, and chemicals can't get throughout a reservoir. So we're at the present time, we don't have an approach to consider in shale.
Yeah, we are leaving, but a lot of oil and gas down there, since we are drilling, I mean.
Well, as I said.
And causing all this damage.
Well, you said it's a very mature, conventionals are mature. There's still 70% of that oil stuck down in that ground, trillions of barrels of oil stuck. So there's opportunities in both.
Yeah, and so we are not going to see gushers that we have seen it in the conventional, in the unconventional. We are not going to see it in the unconventional. There might be a lot of pressure in the well down there, but because of the low permeability, and please correct me, low permeability and low porosity, this pressure that's down there is not going to be transferred to the surface. And are you doing anything in terms of on the unconventional, breaking that space? Up to the
answer is very easy, no. Well, we're still at a stage where we're developing and optimizing and deploying our technology around the world for the low-hanging fruit. So we need to play that out for a while. And
although I heard that chemicals is the next solution to have better recovery from these unconventional wells.
Well, Yeah, we'll see. I mean, it's early enough, we don't know.
Okay, you want to keep it secret for
But I'm
now?
gonna stick to the easy stuff
Yeah.
until we be able to.